Hello, this is Reza Mohajarnoi, and this is my presentation for the final project, the project of my course, Big Data Analysis. And the project is about RAS code generation using DeepSeek. In fact, I wanted to do something new, something novel in terms of the target language because we have everyone almost using Python and maybe more well-known languages such as maybe C and C++. So I tried to maybe while fine-tuning the network, fine-tune that on a specific novel one, more novel one which is Rust. Rust is a low-level language which gives you a good access to hardware, but on the other hand, it has some advantages of the higher level languages such as Python. This has a garbage collector. I think this is needless to say that Rust is a programming language of the future. So this is because of that I chose Rust and I use DeepSeek because this is well known for its being light, its lightweight model and parameters and the options this gives us to fine tune that or change it. For example, I will talk about that in future slides. So uh, this is in fact, in summary, DeepSeek coder fine-tuning, and it's not changing the architecture, doing something to the model itself. I just chose the model and pulled the pre-trained one and tried to change the parameters and not just use that in a specific application. I chose to change the parameters, fine-tune that. Something that most of the papers nowadays do. And this is somehow a step forward to help me maybe improve my research aspect of life too. So it's not just a project for me, it's a baseline for my future. So let's go to the other slide. The challenges in this project. I could count more, but the most important ones are here. Um, just as I said, the code generation has been a novel one. Rust by itself is the more novel one. And DeepSeek is a novel model too. So I tried to combine two novel things, one novel model and one novel language, the less discovered language. I think so. And since my experience of fine-tuning, my experience of LLMs working with them is so limited, so this was some adventure for me too. And as I said, ROS has not been discovered as it should have been, and uh, specifically in code generation, and maybe in future in other applications, I will use it. This model I shared with you, and again, these workings with Hadoop and Spark are still my new skills that I just learned in this class. So with this scale and size, I hadn't used Hadoop and Spark and big data mm, concepts. So again, this is my experience, one of my first experience with this scale of Hadoop and Spark. So these were my challenges, and being new to this area, to this field, uh, was a challenge itself, a gap itself for my uh, own experience and background. So I tried to use Hadoop for storing my data set. My data set is Stack Rust, which was in raw, it was about 10 or 11 gigabytes. I tried to use Hadoop to save it, and as you can see that this is the server in computer science lab. This is one of those GPU machines that we have, and I tried to use that because my laptop ran out of memory and resources to handle this. So this is what you see of my data parquets of the Cycross data, how it was saved. And this is one of those requirements, those feedbacks I got from you that should have solved for my next iteration. Here's a screenshot of my Hadoop usage as a big data concept that I had to use. And here we can see how these are available for retrieval. This data is now stored in the local Hadoop and is available for use in future for my um, project that I use it. And this is how my solution is, fine-tuning. And I used supervised fine-tuning trainer SFT QLoRa/LoRa for this problem. This is because still, although I had some good computer available for me, but still these networks are too big. So any quantized method, any quantized solution would be more prior. So I used quantized weights, maybe down to 4 bytes, 4 bits, maybe even. And uh, as you can see in this solution, we have the formula of W plus A multiplied by B. Multiplied by B is these two adapters that are these two matrices are multiplied by each other and then added to the W we have here. And as you can see, we have the messages, prompts, and finally our output weights, which are going to be merged into the original network. And so our network is going to be fine-tuned. And my network I chose to work with initially was DeepSeek Coder Instruct, but then I came to the conclusion that I should have used DeepSeek Base, not DeepSeek Instruct, because my training dataset and test dataset were not conversational, basically. So I had to use DeepSeek Coder Base. And this took me actually a long time to understand that I had to use DeepSeek Coder Base in the first place. So I understood this late, but still I was able to obtain some valuable results, better results. At least I can say that I improved the network by by fine-tuning using Rust specific data sets. And now for Rust problems, it's better. My model works better. And here's how I prepared the data. This is a file I used for that, prepare DeepSeek messages.py. You have access to that file. I will share it with you, but you should just navigate into the project tree Here's how they seem before being processed, and then we have these. We just add some constant um, prompt to it, message to it, and then specify the roles of each prompt. And this final one will be used as our label, how the model should work. So this is how the data was preprocessed. This is again one of the things you gave me as feedback that I should have kind of clarified. So here it is. Here's how my preprocessing messages data worked. And to as a framework for evaluation, I use multiple, since we know that my test data was specific to Python. We know I'm working on Rust data. So uh, Python is not Rust. Some translator needs to be for this problem. This is a translator, in fact. This framework translated Python files, Python um, code into Rust so that I could take advantage of that, and even for my evaluation to generate pass at K metric, this was useful. So I used this open source project as my testing framework. And here are some um, output output codes that were generated by my network by the fine-tuned one, and they had to be saved to be evaluated by the framework, multiple framework. And these are the things my network, my model received and generated. This is the prompt, and these are the completions that my model, my fine-tuned model, suggested. And path at K are is gonna be um, calculated based off these trials. In how many tries it was able to work and give a reliable answer. And here is a window of the results. I should mention that uh, the tests take long. Each test, even with the 1 billion parameter model, takes a day, even with the GPU. So it's not possible for me to test a whole maybe 100 iterations of that model. Uh, I I got some results that are enough to show that I had some improvement. So here you can see that for DeepSeek coder base, which I understood late that was the option for me to test my data that is a suitable model for my data training and test. We have some 34 and 18 for one pass at one and pass at 10. But here for my merged network, which is in fact my fine-tuned one, we have 21 and 46. This is an improvement. And for a pass at 100, sorry, here 30, 18 and 34, 21 and 36. And on the other hand, we have for pass at 100, 44 and 46. So for all of these metrics, pass at 1, 10, and 100, my fine-tuned model has some improvement. And as future work, we can do a lot of things. For example, we can do fine tuning. We can implement that SFT on heavier models. This model, as I just mentioned, was the lightest of the lightest. So we still have some heavier DeepSeek models. I just used 1 billion. We can use 33 billion. We can use 6.7 billion parameter models. So I used lightest of them, and still DeepSeek, even the heaviest of them, uh, is one of the lightest networks. So still we have option if we have the resources and hardware to and also time to fine tune even heavier networks. And another work that can be done is uh, we have other languages, other options, other applications such as maybe the assembly or assembly as a problem. We have C++. plus plus. I think um, work has been done on C++ plus plus enough. So assembly or even machine language, machine code is some option to go with for future. And finally, I think that the instruct version with instruct suitable data set for training and testing is still an option. So even though I used deep-coder base for this because my data limited me to this network, we can still have some conversational data to use DeepSeek Instruct to fine-tune such a network and evaluate how fine-tuning this network works. This is what I did, and thank you for your attention and time to consider my project. I know that it has some black holes still because the project is big. I myself wasn't familiar enough with either um, Hadoop and Spark before, and fine-tuning. These are all new to me, but I did my best to handle this, and I hope this is enough for this semester. This was my first time to uh, fine-tune a model, a big model, and before this project, before this doctoral degree journey, which is still I'm in the first year. I hadn't worked with LLMs at all. I just worked in my master thesis on CNNs. So I hope that's enough. And thank you for your attention.